Welcome to The Explainer. Today, we're tearing into a comprehensive analysis of the computational frontiers defining 2026. This year is widely known across the industry as the Year of Truth in Technology. We are officially witnessing a fundamental shift, moving away from treating AI as just this isolated, experimental tool and really starting to rely on it as an autonomous, self-healing foundation that's literally powering the global digital economy.
Okay, let's dive right into this. The technological landscape of 2026 is defined by a massive, sweeping transition. We're totally past that novelty phase, you know? The days of just generating a funny text poem or a cool image are behind us. We're entering an era where computational systems are building, managing, and securing themselves. It's a complete reshaping of the global digital economy. And honestly, the organizations and individuals who truly grasp this transition, those are the ones who are going to thrive. To wrap our heads around this massive leap, we're going to explore a horizon arc covering 5 major areas today. Number 1, Agentic AI, moving way beyond the prompt. 2, vibe coding, the rise of AI-native software. 3, physical frontiers, we'll look at BCI and robotics. 4, quantum threats and digital trust. And finally, number 5, the future of innovation. Let's get right into it.
Section 1. Agent AI, Beyond the Prompt. We're talking about the huge shift from reactive to proactive. Now, what's really interesting here is the stark contrast between the AI we've all gotten so used to and the AI that's taking over in 2026. Traditional generative AI is strictly reactive. You give it a prompt, it spits out an isolated output, and then it just stops. It waits for you again. But agentic AI, that's completely proactive. It operates on a continuous loop where it perceives its environment, formulates a plan, and then takes real action to achieve a goal, all with minimal human intervention. It adapts on the fly. It's a real game changer. And when you scale this autonomy up, you get multi-agent systems, or MAS. Think of it like a massive digital assembly line of specialists. Instead of relying on one gigantic AI trying to do absolutely everything, you have a collection of highly specialized agents interacting to achieve shared goals. A brilliant example from our sources is a loan application workflow. Instead of a human manually routing PDF files around an office, you have a journey orchestration agent coordinating simultaneously with specialized agents that handle the pricing, the risk assessment, and the fraud detection, all happening at once. To understand how these agents actually pull this off, we need to look at their architecture, which operates in 4 distinct steps. First, they perceive, by ingesting real-time data right through APIs. Next, they plan, by breaking down high-level goals into sequences of smaller, manageable subtasks. Then they act, physically executing those tasks on external systems like a CRM or a SQL database. And finally, memory. They use memory to maintain state and context over long periods of time. But here's the absolute kicker and why this matters so much. As these agents start acting autonomously on live production systems, our risk shifts dramatically. We aren't just worried about AI generating a hallucinated, incorrect fact anymore. We have to worry about actual operational failures. An agent making a bad change to a live production database is a whole different ballgame.
All right, Section 2, vibe coding, AI-native software and the shift from syntax to semantic intent.
So how do we actually build these systems today? Well, there is a radical shift in software engineering happening right now, captured perfectly by the term vibe coding, a phrase coined by Andrej Karpathy back in early 2025. Instead of typing out imperative syntax line by painstaking line, a developer acts a lot more like a product manager. You describe the high-level functional intent, and crucially, you provide qualitative descriptors. You know, the vibe, the tone, the style, the emotional resonance of the app. The AI agent takes that natural language and handles all the heavy lifting of generating the actual code. This is a massive democratization of development. It lets creators focus on the big picture instead of spending 3 hours hunting for a single missing semicolon.
And this brilliantly illustrates the actual reference architecture for intent-driven programming. It starts off with intent definition, where you write out your natural language goals. Then comes blueprinting, where the system creates an architectural strategy artifact. Next up is execution, where the agent installs the dependencies and literally writes the code for you. And finally, verification. This is where sub-agents actually launch web browsers to test the UI and ensure it matches the exact vibe you asked for. Because of this workflow, small, nimble teams can now rival the output of massive development hubs. It's wild.
However, you know this paradigm isn't without its critics. Developer Simon Willison pushes back really hard against the careless use of these tools. He argues that if you're just blindly accepting code, you are asking for trouble. Willison champions what he calls vibe engineering. It's a much more disciplined approach where, yes, you still use AI to generate the code, but you enforce strict human review, automated testing, and deep security audits. Because if you don't, you run the huge risk of accumulating a massive, completely unsustainable amount of security debt because the AI ignored established architectural patterns.
To really back up that need for caution, consider this highly surprising finding from a recent Metro study. Get this. They found that experienced open-source developers actually took 19% longer to complete tasks using early 2025 AI tools. Crazy, right? Actually, scratch that. It wasn't just longer, it was vastly more frustrating for them because they spent so much time trying to untangle and debug code that the AI had completely hallucinated or just implemented poorly. It's a really powerful reminder. While vibe coding can absolutely accelerate your prototyping, it is not a magic bullet. You still need proper verification skills.
Okay, moving to Section 3, Physical Frontiers. This is where AI leaps off the screen and meets the physical world through BCI and robotics.
Let's step away from the digital realm of software for a second and look at how these autonomous models are breaking out into the real world around us. The breakthroughs in embodied AI right now are just explosive. We're seeing generalist robots being trained in these massive, insanely photorealistic simulations called Malmo spaces. Because these simulations are so accurate, the AI policies achieve what's known as zero-shot transfer. That means they work on physical hardware in the real world on the very first try without any extra training. We're also seeing biohybrid robots using artificial tendons to move way more naturally. On the human side of things, brain-computer interfaces, or BCIs, are advancing rapidly. Non-invasive EEG arrays are closing the performance gap with invasive surgical implants. And affective computing? It's literally translating our neural signals into recognized emotions right now.
But integrating consumer neurotechnology so closely with our actual brains brings us to a massive, incredibly urgent question for 2026. How do we protect the privacy of the mind? Think about it. If wearable trackers and AI can decode our attention spans, our moods, and even translate our cognitive semantics, we have to establish firm boundaries. Researchers and lawmakers are scrambling to design technological constraints to protect our internal emotional processing and our inner voices from unauthorized algorithmic intrusion. It's a fascinating frontier, but one where rapid innovation absolutely has to be met with serious guardrails.
Which brings us perfectly to Section 4, Quantum Threats and Digital Trust, Securing the Infrastructure.
So if AI is actively writing our software, orchestrating our businesses, and potentially reading our cognitive states, how do we fundamentally secure all of this infrastructure? Well, the looming threat on the horizon is the cryptographically relevant quantum computer. This is a machine that could easily break our current public key encryption. Organizations right now are absolutely terrified of harvest now, decrypt later attacks. That's where hackers steal encrypted data today and just hoard it, knowing full well they can use a quantum computer to decrypt it a few years down the line. Because of this, the primary defense strategy in 2026 is crypto agility. This is your organization's ability to seamlessly swap out old cryptographic algorithms for new ones via simple configurations without having to tear down and rebuild your entire system architecture from scratch.
So the crucial point here is knowing exactly what you're swapping those old algorithms out for. The newly finalized NIST Post-Quantum Cryptography standards are the new foundations for digital trust. We have FIPS 23, which standardizes Kyber for key encapsulation. That's replacing things like RSA. We have FIPS 24 standardizing dilithium for digital signatures, and FIPS 205 utilizing Sphinx Plus, which takes a stateless hash-based approach. These new mathematical bases, like lattice-based cryptography, are currently believed to be highly resistant to quantum attacks. To actually get your organization there, Isaka released a highly actionable 12-month playbook for digital trust professionals. It's super straightforward. In Q1, you organize. You have to inventory where your public key cryptography actually lives today and classify your data, prioritizing absolutely anything that needs 10 to 20 years of secrecy. In Q2, you pilot hybrid handshakes. This is where you combine classical and post-quantum algorithms, so an attacker would literally have to break both. Q3 is all about modernizing your public key infrastructure and updating those vendor contracts. And finally, Q4 is when you expand that deployment to your external-facing services. The race has already started, folks, and it begins with simply knowing what data you need to protect right now.
Finally, Section 5, the future of innovation. It's time to orchestrate the next era.
Let's bring this all together. We've covered a massive horizon arc today, all the way from multi-agent systems acting autonomously, to vibe coding completely shifting how we build our software, right through to generalist robots, brain-computer interfaces, and the urgent, very real push for post-quantum cryptography.
The common thread tying all of this together is transition. We are moving away from being passive tool users, we're becoming proactive orchestrators of an incredibly complex, fast-moving digital economy. The competitive edge in 2026, it doesn't belong to the person who can type out code the fastest anymore. It belongs to the person who possesses deep verification literacy, who builds systems with crypto agility, and who leads with ethical foresight. So, I'll leave you with this provocative thought to reflect on today. In this totally new era, are you ready to stop writing syntax and start orchestrating systems? Thanks so much for joining me for this explainer. I really hope it gave you some incredible insights into the technology that's shaping our very near future. Keep learning, stay curious, and I'll catch you next time.